So this is my vellum cloth tutorial, and we're going to be looking at how we can tear cloth and how we can stretch cloth in Houdini 17.5. So the first thing we need to do is create the cloth itself. So we're going to use a grid, then just click enter and it will pop up in the middle of your scene. So the first thing we need to do is to rotate it to where we want it to be. So we're going to click in on the grid, click tab, and then type transform. We can just connect that up, just hit the little blue icon here. Then we're going to make sure it's on this tool here, and we can just rotate the item, the grid. We can rotate the grid all the way around, like so. Or you can just use these ones here. So we can just change this here and make that 90, so it's exactly how we want it. And then we're going to need to pull it up a bit, so it's slightly just off the ground, like so. And this will be our cloth. So if we go back to the grid itself, we probably want to increase this to about 50, just so it gives the cloth stretch a bit more detail and it will look a bit better in the end. So this is the general setup there. Then we need a collider. We need something to be able to stretch the cloth and to rip the cloth. So we're going to go and get a sphere and just click it in the scene. And we want this to be about in the middle, but you can put it where you want. About there will do. Perfect. And then we're going to want to keyframe this. So to keyframe, you can use Alt on your keyboard and then just click these here. And that will just for the translate, so it won't be for anything else, but for this tutorial we'll just be doing the translate tool. So that is set to frame 1, then we'll probably do a couple of seconds and we'll move it just through the cloth so we can get a good rip and a good stretch. And then we need to just redo these. And when they're green, that means that they have been keyframed and it will record their position. So now if we scrub the timeline, you can see it moves straight through the cloth. So this little icon down here, the little watch or clock itself, that means that it will play at its actual speed. So when we hit play, it will look like that. Perfect. And then we can probably just bring this down to probably 120, just so that the simulation won't be as long. And that is our setup. So we have the cloth itself, and then we have the collider. And that is a very, very basic setup, but we can go into more detail later. So now we need to actually make the simulation itself. So we're going to click on the cloth, we're going to come along here to Vellum, and you can click Vellum cloth here, but for the purpose of this tutorial we're going to create it from scratch. So we're going to go in, we're going to get a Vellum cloth node, I'm going to attach that to the very first point here, like so. We're going to get a Vellum solver, and this has to be a Vellum solver, it can't be one of the other solvers, so just make sure it does say Vellum and link that up. So the next node you can use, which makes it look a lot better, is the post-process node. The Vellum post-process. So this will just make any like hard angles or any polygons which don't look right more detailed, and therefore make it look a lot better. So that is the general setup. So next thing we need to do is make the collider itself actually have contact with it. So then we want to look in here, and this one here is for your collision. So we're going to get an object merge, place that there, and attach it in there. So then we want to come up here, click this button here, and we're going to find the object itself, which is the collider, and just click accept. And that means that will now be the collision. So if we go back to the very start and click play, you can see that the cloth is just fell down. And if you actually look, the transformation of this is actually down here. And this is because you need to, into this object, change it into the object. That will mean the object created out here is going to be exactly the same object in here. So it will take all of its data and positioning with it. So once that's in place, if we do it again, you'll see the cloth just falls. That's because the cloth hasn't been pinned yet and has no data to tell it that it should stay in this position. So if we go to the constraint now, and we want to go down pin animation. So if we click the little arrow, you get all these blue lines. Now what I like to do is hold shift and just drag and select a group at a time. This will just mean the yellow ones itself are going to be pinned to that exact position throughout the whole simulation. Then just click enter. And now if you look closely, you can see all the little constraints within the simulation. And this is something that is quite new to Houdini, and I think is a lot better than the old ways of doing it in like Houdini 16. It's the fact that the Vellum constraint allows you to have a bend constraint and a normal constraint. So now if we go back to the very start of the simulation and click play, you can see the object now comes straight through and stretches the grid, but the positioning of these ones around the edge have all stayed exactly the same. So once that's all done, we can then look into the more detailed things. So if we wanted the cloth to stretch a bit more, or maybe stretch not as much, we can change these ones. So it's the stiffness, and if you hover over them, it actually tells you how it works itself. So changing factors of 10. So if I was to put this up to 20, it'd become double as stiff. Probably easier showing on a more detailed object. So what we'll probably do next is come out of here and we'll change our object. So we'll get a test, get the rubber toy, and this will be our new bit of geometry. So we're just going to delete this out and move it down ever so slightly. We don't want it to collide with our pinned objects, just so it's in the centre. So I'm just going to scrub the timeline just to check that it moves. We'll go back into the cloth and we'll play this through. This is what I was on about earlier. The more columns and rows we have, the more detailed it will be, because as the object collides with the grid, it does stretch it quite a bit, and you can see that there's a lot of sharp angles, but this will heavily increase your simulation time and render time if you put this up anymore, but for this simulation it's fine. So now we're going to look at the bend constraint. So we'll make it a bit more stiff. And as you can see, it doesn't bend as well around the object itself. So the next thing we're going to look at is how to rip the object. So this one's a bit more complicated, but it's still very simple within the whole Vellum solver itself. So the first thing we're going to do is keep the grid and the transformation. If you just hold Y, you can disconnect this. And then this is our grid. We're going to add a remesh. Place that in here. What this will do, it just breaks it up a bit more. And we can probably put this up a bit. And edge length, we can probably bring this down just to get smaller triangles. Like that. And then what we need is an edge fracture. This will create our breaks within the cloth. Like so. And then if we click this button here, you can actually see the breaks themselves. And there we go. So we have quite large breaks at the minute, but we can change this by toggling up here so that we get more pieces. Then what we need to do is then we can plug this straight back in here. And one thing which is different in the whole Vellum solver itself is that we need to move these down and we need to get a Vellum weld. And this is literally does what it says. It will weld the points all together themselves. So if we look at this one now, you can actually see the welds between the individual pieces, and when we move the stiffness, this is what's controlling the stiffness between the bonds themselves. If we go back down here, so if we do play this now, what you'll see that it actually doesn't break, and this is because if in the Vellum weld themselves, you have to turn it on, so you have to turn the brake on, and this is controlling the constraint. So if you want it to break really quickly, have it low. If you want it to take a little bit more time, maybe put it to 2. So what we can see is happening here is one thing that I forgot to do, which is one of the main parts, is if we go to the Vellum cloth, the points themselves have all changed because we've used a remesh. So I'm just going to click off here, hold shift and redo my pinned animation points, and then just click enter. We move back down, and now we want to try it. Click play. And the cloth stretches. If we want the rip, go back down to the break, and we put this at 0.5. we go, the cloth starts to rip, as you can see there. So if we come out of the simulation, this is what the cloth will look like. And it will start to rip. Maybe we probably should have used slightly bigger pieces, but we can go back and change that by going into the cloth, come back up to the edge fracture, and we'll get rid of some of the pieces. About 22 will do. And then we have to go back. Go back to the cloth constraint, go to the pin points and just make sure they are done, and then click enter again. So now there should be larger pieces and still a cloth rip. Yeah, so there's still quite a bit of constraint between the bonds of the pieces, so we can lower this a bit more by going into the weld, maybe putting it down to 0.2. We can play again. As you can see, the cloth rips a lot more easier now. And one thing we do need to remember is once we're happy with the size of the pieces, we don't actually need to have the pieces on, so we can turn that off. Then the next thing would be adding a texture. So we first need to create UVs for the actual grid itself. So we're going to use a UV, flatten, I'm going to put that in there. Or actually, we'll do it, just shake it. We'll put it in before this, like so. And then we're going to get a material and add that in there. So the next thing we'll do will be creating a material. So we come over to the material palette, drag and drop a principal shader in, and we're just going to make this, change the colour for now, make this red. We're going to come back, click on the material, then we need to add a material by hitting this button, this principal shader, and now we've got a red object. We come out, so we now have test geometry ripping through a cloth. So next thing we can look at is now individually go through the nodes just to show you how they work and what they actually do. So we've also got the grid itself. So this is where we control the detail within the grid. This will heavily increase your render time, so probably wouldn't put it up much more than this. Then we have the UV itself, so that we can add a material or we could add an image onto this. The remesh, so this is controlling the length of the edges itself. So if we want smaller remesh pieces, then we'd lower this down, and then we can get a different iteration of this. Next one is our edge fracture. So if we want to look at pieces themselves, tick this box, and then we can see our pieces, and then we can actually change what we want it to look like. So maybe something like that. The next one, the object itself, if you hover over it, it does actually tell you. So this is our collision geometry, and make sure to use this transform into this object. We then have the main thing, is the pinpoint of your animation, which you can hold shift and then click enter. And then we have the stiffness. We'd probably lower this down to 10. If we want the fabric, the cloth itself to be more loose and flexible. Then we can scroll down. One cool thing about this is if you want it to look like plastic and hold its position after it's been like stretched and ripped, that's what this does. Then we have the bend constraint, just to understand a bit more what is actually happening within the simulation itself. So basically the old way of doing it is the point-based dynamics, and as you can see here you have multiple points which can then have a stretch between them, so how far the points can move away from each other. But with the new Vellum cloth, it also has this constraint, so you're controlling the distance and how much they can move between each other, but there's also a bend constraint, and that allows the points themselves to rotate and have a different angle. This means that when we do the cloth simulation itself, you actually get a lot more detail around certain things, and it's I find a lot quicker and easier to use, as there's two main toggles, one for your stiffness and one for your bend. So your next node after that is your Vellum weld. So this is where you can control the welds of these points themselves, which can be seen as the little white lines between the pieces. Then moving down to the solver, so this is where you can control your forces. So if you want into wind, which we don't, or if you wanted no gravity, that can be changed there. See, but it doesn't make that much difference, but sometimes in a simulation, before the collision has actually happened, you might get the cloth to sag around here where the points, if I was to put this on -20 for instance, you can see the object itself, the cloth itself, starts to move and droop in that where it bounces slightly there. I stop this just by putting this on 0 and making sure there's no wind or wind drag on. And the cloth is still until the cloth rips itself. And you still get this look as if there was gravity, but you don't get the cloth sagging as much. The final one, but one of the most important ones to make the whole simulation look good, is if we were to click this one for instance and look at some of the pieces here like that, and then we click this one, nothing happened. And there we go. So this is the next node is the post-process node. This is a very important node for high detailed cloth simulations, probably not for something like this, but if you're going to look into something trying to climb through the wall, such as things like Stranger Things like this, This is where you'd probably want to use it a lot more, as you can see in the background in a minute, where the monster itself starts to stretch and break through the wall, and there's lots of tears and lots of different rips within the simulation. That's probably something which should help. If there's points within the cloth where they get tangled up or it doesn't look quite right, you can turn the detangled on, and that will generally sort it out. And let me put this on 3, and then you can change. As you can see, like around here and around up here, it'll actually try and smooth the cloth and get rid of any imperfections. But we'll leave that at 0 for now. And then if you want the thickness of the cloth itself to be thicker, because at the minute we're only using a grid itself, but if you did want that to look a bit more like fabric, then you can just click this and you can control the thickness of the cloth. We'll leave it like that for the test. And now if we scroll through, make sure it's on. One thing we need to do is to turn the pieces off, come out, and click play. And there we have a very, very simple and beginner guide on how to set up a cloth simulation using Vellum in 17.5. So this is just a more advanced version of what we've just done. The exact same setup, the only difference is we are now using an animated character which has been rigged. So you can get these rigs, this is where I got mine from anyway. So you can get this rig from Mixamo, and you just put in your FBX file here and make sure it says FBX, and then it'll come up with drop down menus, and you just make sure it says mixamo.com, and that will bring in the whole animated frames of this character, and as you can see he just moves into the cloth. So now I've transformed him so he's in the right location and in the position I want him to be, and then we have our material and we have our out node. So then if we go into the main simulation, exact same setup, we've got the post process, the solver, the weld node and the cloth, and we've got the grid with its transform material, its remesh, don't need that, and its edge fracture. The only difference being we've got the same object coming in, but we have to use an agent Vellum unpack. That's what the only thing it does is it brings all the information in and it allows it to be processed by the Vellum node itself. So if we play this, you can see it's a lot of a heavier simulation this time, and you can see the rip here and the hand which is broke through, and as it's just a looping simulation, it'll go back through and rip the cloth again. I think this gives a very nice effect, but if we look closely here, you've got a lot of stretched sharp polygons and edges, and it doesn't look the best. So this is just on the solver. If we go here, you can see there's a very slight difference. It just smooths it out very, very slightly. But if we go here, and then we want to detangle probably twice, maybe 3 times, and we might want to add a bit of thickness. I'll zoom in a bit and have a look. Probably a little bit more, maybe 1.2. There we go. We want to blur this So now you can see from this what it was, where there's a lot of angles, to now here being very smooth. All it's done is it's looped the subdivision itself continuously, and I've put it on 1, and it's detangled all of the faces which might have been colliding, and I've put that on 3 passes, and then I've made the thickness of the cloth to 1.2 just so it's not so flat, and then we get this as a final result. Again, this is a bit more advanced, but it's still very easily done using the basics of vellum cloth, but the final result is looking a lot more smoother and a lot better within the individual shapes themselves and the rip around the edge. There are still slight little bits that need to be worked on, but for a tutorial, I think this shows you a very easy way to make quite a high standard cloth simulation. The final thing I just wanted to go over is the points themselves. Last time it was just a very good square. Last time it was just a square like this. Now this is good, but on the actual simulation you can see the very harsh, sharp lines on the simulation. So what I like to do is just go around and delete little chunks, just so there's no harsh lines and it looks a bit more realistic. And then just make sure it doesn't collide either, as he does have a very broad swing. So, and as you can see, there's not as much harsh straight lines around the cloth when it's being stretched. You got a lot better rip within the cloth, and there's no jagged edges either around the head, and you could even add more of a remesh, but obviously for render times and the purpose of this video, probably not the best idea. And that is the end of this tutorial. I've gone over how to rip cloth in an easy simulation. We've looked at a more advanced simulation using mixer mode characters and rigged characters, and I've also looked at how to just stretch cloth itself.